So once again, a very good morning to you. So we are proceeding with more examples on roots of quadratic equation. So we are going to have a series of more examples which are on roots of quadratic equation. So we shall start with example 1. It goes, the equations y squared plus py plus q equals 0 and y squared plus my plus k equals 0 have a common root. That these two equations, they have a common root. Show that q minus k squared equals m minus p into pk minus mq. So the question goes that if the equations y squared plus py plus q equals 0 and y squared plus my plus k equals 0 have got a common root, they want us so that this expression is equal to that. So what do you do when a question comes to that? Remember, I've been dealing with the roots of the equations as alpha and beta. Now, it is upon you to choose one of those roots, because you can baptize by saying let the common root be beta, let the common root be alpha. It will depend on what you want. So let's go. Cancellate the common root. Let the common root be alpha. Let the common root be alpha. May have used alpha. It means where I see y the variable, because y becomes a variable, I'm going to substitute where there is y, I put there an alpha. So let's go on the first one. Where there is y, replace it with alpha. It becomes alpha squared plus p alpha plus q equals 0. I can say this is the first equation. I also go to the second one. Where there is also y, I replace it with the alpha. It goes alpha squared plus m alpha plus k equals 0. I say this is the second equation. Then from there, how can I eliminate alpha squared? I'm going to subtract. I will say 1 minus 2. Can we subtract equation 1 from 2 or 2 from 1? Even if you say 2 minus 1 or 1 minus 2, no problem, such that I can eliminate that alpha. So we go alpha squared minus alpha squared, I come out with a 0. P alpha minus m alpha, what do we get? Here we shall have P alpha minus m alpha plus, come to this, q minus k, it becomes q minus k. The whole thing equals 0 minus 0, 0. So can we make, from this one, can we make alpha the subject of the formula? So this one is a positive. Where it goes up comes a what? You can see, we can take this one as once. I can take it the other side. And what is common here is alpha into p minus m, excuse me, that, equals negative into q minus k. So can we make alpha the subject? Alpha alone becomes push in, I can push in the negative, or I can leave it like that, but let me push it. When you expose a negative, you're going to have k minus q after putting that one affects in that manner, all over p minus m. This is my alpha. So after getting alpha, I can maybe call it equation star. Then I can say, put star in any equation, either in 1 or in 2. And I can either substitute in equation 1 or equation 2. Where I see alpha, I replace it with this stuff. I can say, put equation star in 1. Put equation star in 1. So our equation star goes, our equation star is already alpha equals k minus q all over p minus m. So in our equation 1, our equation 1 is says y squared plus py plus q equals 0. But we have already equation 1 is only having, it is not terms of y. Equation 1 is in terms of alpha. Equation 1 is alpha squared plus p alpha plus q equals 0. So when I see alpha, I put in k minus q all over p minus m. So we go, this becomes k minus q all over p minus m, the whole thing squared plus p into, do we know our alpha? Still is k minus q all over p minus m, then plus q equals 0. So can we expand as usual? The square goes on all the numbers in the bracket, as the last time we are looking at indices. So this becomes k minus q, the whole of it squared, all over p minus m, the whole of it squared. The square goes on all sides. Then plus p into k minus q all over p minus m, then plus q equals 0. So look at this scenario here. What is the LCM of the denominator? The LCM is p minus m squared. So after realizing that the LCM, because this is like out of 1, so our lowest common multiple is p minus m, the whole of it squared. So from there, we are going to multiply by the LCM on both sides. We are going to multiply here by p minus m squared, again here by p minus m1 squared, again here by p minus m1 squared, every corner. And when you're multiplying, go start with the LCM. So this becomes, when I multiply this one, I'm going to remain with k minus q squared plus the whole of this one, the one reduces, we remain with p into k minus q into p minus m plus q into p minus m, the whole of it squared equals 0 times anything. Automatically you're going to remain with a BL. So we move on. We go ahead and try to open the brackets where possible. Our interest is to come out with this. So what am I remaining with? I'm having k minus q, the whole of it squared, plus p into, we are free now to open the brackets here, k times p, I'm coming out with pk or kp, k times m, I get minus mk, q times p, I say minus pq, a negative times a negative, I say plus mq, plus q into p minus m, the whole of it squared equals 0. So we go ahead and we try to collect like terms where possible. Then from there, we take this one in the other side also. We try to expand it in the other side. But p minus m, the whole of it squared, is the same as what? Remember from Pascal's triangle? This is the same as when you expand, it means p minus m, again into p p minus m. So when we open using Raymond's, we are going to come out with p squared minus 2mp, then plus m squared. But outside we are having a q into. Then when you say q into p minus m, the whole of it squared is the same as q into the whole of that stuff which I've come out with, which is a p squared minus 2mp plus m squared. So when we try to open, you push in every stuff. This becomes p squared q minus 2mpq plus q m squared. This is the expansion of that stuff. So we are going now to substitute in all those stuffs until when we come out with what was required from us. So when we try to move on, we are trying to move on now. We are here, we are having k minus q, the whole of it squared, plus, after can we insert in the p, plus p squared k, okay, minus mpk, we are pushing in that, minus p squared q plus mpq, then we say plus this one which I've already got, plus p squared q minus 2mpq, then we say plus qm squared, the whole thing equals a there. Then from there we are free to go ahead and collect like terms where possible. I told you with these numbers you need to be very, very careful on what you are already doing. So you can see p squared q is going to disappear with this. We have also got mpq can also be collected with this. So can we collect? We are having k minus q, the whole of it squared, plus p squared k minus mpk. This one is going to be collected with that, we remain with the negative mpq, then we say plus q m squared equals a there. Then from there we are free to take all these stuffs in the other side. Can we take all these ones in the other side and we see where possible? Or I can even bring the stuff, so can we collect items? Let's first take them the other side. So we are remaining with k minus q, the whole of it squared, plus can we look at those ones which are common, like mpk, and here there is mp, then q. Can bring these ones here, these ones are common and these ones are common here. So we are going to have plus, what is common here? What is common is a pk. Nice. Then what we remain with? We are going to remain with p minus m. Okay. Come here. What is common? What are you seeing here? I'm seeing a m, and again I'm seeing also m. I'm seeing a q, again a q. So what is common is a negative mq. So we are going to remain with p minus m, because one m is already outside, equals a there. Again, see here, what is common from what we did during quadratic equations? What is common? You can see p minus m is again common. So we are going to guide, this is k minus q squared plus p minus m, it is already out, into pk minus mq, and the whole thing equals a there. So from there, look at this scenario. This one is a positive. When it goes out, it becomes a what? Becomes a negative. So we're going to have k minus q squared equals, it becomes, because it's a positive, when it crosses an equal sign, automatically it becomes a negative. So we're going to have a negative into p minus m, again into pk minus mq. So by me seeing now here, a negative, we insert in the negative. A negative times a positive comes a negative. A negative times a negative, we are going to come out with a positive. So this is the same as k minus q squared equals m minus p. I think you have got that one, because when you try to insert in the negative, this one becomes a positive and this one becomes a negative, into pk minus mq. So, but from Pascal's triangle, k minus q, the whole of it squared, is the same as q minus k squared. If you expand this and this one, all of them, they bring out the same answer. So instead of this, we are going to write that one. So we are going to say this becomes q minus k, the whole of it squared, equals m minus p into pk minus mq. And we have already proved as they required. Hence proved. So you can see we have tried so that if they have a common root, this is what is coming out. In mathematics, we don't gamble. Avoid gambling. Follow the steps like what I've done. And always go slowly. Don't rush. What are you rushing for? Remember, this number comes in section A and it carries 5 marks. Why do you miss those 5 marks? That is simply because you are rushing. So this is the first item, as we are going to proceed to the second example.